Okay, we're going to finish up section 9.2 today, continuing to look at ellipses. But today what we're going to do is we're going to look at the problems essentially in reverse. What we've done so far is we've started with the equation of an ellipse, either in standard form or general form. And then what you guys have done is you have looked at how to find the center, the vertices, the co-vertices, the foci, the eccentricity, and the graph of the ellipse. Well, today we're just going to do that problem in reverse. We're just going to make sure the arrow can go in the other direction as well, so that when it's all said and done, we can work the problems in both directions. So now, today, given some information about an ellipse, given the center or the vertices or the co-vertices or the foci or the eccentricity or even the graph, I want you to be able to work backwards to tell me what the equation is going to be. Okay? All right. So the way we do that, let's take an example. This will be a relatively easy one. Given the vertices at negative 3, 8 and negative 3, negative 2, and the co-vertices at negative 5, 3 and negative 1, 3, can you tell me what the equation is? All right? Well, on almost all of these, I can't imagine there's an example where it's not helpful to just start by drawing yourself out a sketch of what's going on. So if you just draw a sketch of what's happening here, the vertices are at negative 3, 8, so left 3, geez, that just looks bad. Let me try those again, guys. Left 3, that looks a little better, and up 8, 1, 2, 3, 4, 5, 6, 7, 8. So there's one vertex, and then negative 3, negative 2 is another vertex, right? And then the co-vertices are at negative 5, 3, and negative 1, 3. So you'd have a little picture of the vertices and co-vertices, and of course you don't need it, but you can kind of get a feel for what the ellipse would actually look like. It would be just ballpark, something like that. Now what we need for the equation is, we need to know where the center is. So we need to know the center of the ellipse, because that's going to be the h and the k in the equation. And how do we find that? Well, the center is going to be halfway between the co-vertices or halfway between the vertices. And you guys can easily see that that point then is going to be halfway between the vertices or halfway between the co-vertices is going to be located at negative 3, 3. So we can get our equation started right away. Right off the bat, we can get our basic equation started by replacing h with negative 3 and replacing k with positive 3. But please remember, anything that goes inside parentheses has to be opposite of the sign. So this symbol is positive because the x value for the center is negative, and this value is minus in the equation because the y coordinate is positive 3. Remember, anything in parentheses, opposite of the sign. Okay, now to finish off, what number goes under the x's? The value that goes under the x's is going to be the distance. Let me put it in red so you can see it. Is going to be the distance from the center of the ellipse to the side. In this case, that's going to be little b. Can you tell what that distance is? Well, from negative 3, to negative 5, or negative 3 to negative 1 is a distance of 2. So that number squared, 2 squared, is 4. And can you tell me what the value under the y's is going to be? Well, that's the distance from the center to the top of the ellipse squared. In this case, that's going to be an a distance. And can you guys tell me what the distance is from 3 to 8 or 3 to negative 2? That distance is going to be 5. But we don't put in 5. Remember, it's not a, it's a squared. So 5 squared is 25. Okay, so the entire equation then, x squared plus, oops, sorry, I said that wrong. X plus 3 squared over 4 plus y minus 3 squared over 25 is equal to 1. And of course, this is the standard form for the equation of the ellipse. And if we ever needed the general form, no big whoop-de-whoop, what we'd have to do is get it into general form. First, multiplying both sides by what? Trying to get rid of the fractions. So I'd need to multiply both sides by 100. So if I multiply both sides by, in fact, how about if I write this first one out? So if I multiply everything by 100, so the first fraction the second fraction, and then the right-hand side. The 100 and the 4 are going to cancel, leave me with the 25. The 100 and the 25 are going to cancel, leave me with a 4. And 100 times 1 is just 100. And then if you guys will FOIL, x plus 3 squared is going to be x squared plus 6x plus 9. FOIL y minus 3. Y minus 3 squared is y squared minus 6y plus 9. Use the distributive property, 25 times x squared, 25 times 6x, and 25 times 9. And then 4 times y squared, 4 times negative 6y, 4 times 9. And then just simply get 0 on one side, and then put the terms in the correct order. A, there is no B term. C, D, E, and then the F term, what we'd have to do is put the three numbers together. So 225 plus 36 is 261, and then 261 minus 100 is 161. So this then, let me box that in. I know it's kind of small, but this then would be the general form for the equation of the ellipse. Okay, so please just read directions carefully as you go ahead to figure out what form they want it in, or when we take our test at the end of the year, what form I'm going to want it in. Okay, so let's try a couple more examples. What if I were to give you the vertices and the length of the minor axis? Again, this is going to be a fairly easy one, but please just get in the habit of drawing yourself a picture. So what are you told? The vertices are at negative 5, 2. So 1, 2, 3, 4, 5, up 2. There's a vertex. And at 3, 2. There's a vertex. All right? So right off the bat, you know that this line then is the major axis because it connects the two vertices, the long. And we know that the center is going to be halfway in between. What point is halfway in between negative 5, 2 and 3, 2? What's going to be halfway in between? Negative 1, 2. Okay, so right off the bat we can then replace h with negative 1, and we can replace k with positive 2. Now remember, anything inside parentheses is opposite of the sign, so it reads x plus 1 squared and y minus 2 squared. All right, what value is going to go under the x's is the distance from the center. Let me do this in red so you can see it clearly. From the center to the side of the ellipse squared. And what's that distance from negative 1 out to 3, or if you prefer to go the other way, negative 1 out to negative 5, this distance is 4. Therefore, the number that goes under the x's is that distance squared. 4 squared is 16. And finally, what number goes under the y's is the distance from the center to the top of the ellipse. Or if you prefer, you could go to the bottom as well. Just pick a direction. And do we know how long that's going to be? Well, indirectly we do, because it tells us in the problem the minor axis is 4. So altogether, in this case, from top to bottom, that distance is 4. Let me use my laser pointer. So from top to bottom of the short axis, that's going to be 4. Well, since the center has to be halvesies, that means then that this distance has to be 2, and that distance has to be 2. Therefore, the distance from the center to the top squared, 2 squared, is 4. Okay, and I'm going to choose not to put that one in a general form. If you guys just want to do some algebra for fun, feel free. Okay, next up, this one's going to be a titch tougher because I don't tell you the vertices this time. What I tell you instead is the foci, and I give you the length of the major axis. Again, it's going to be helpful to draw yourself a picture. So I'm going to start by drawing myself out a picture of this fella. So the foci, left 2, up 2. So there's a focus, and 4 to the right, up 2. There's a focus. All right, now if you only just start with that, you know the major axis is going to go through those 2 points, and it's going to go a little bit longer, but for now let's not worry about how long it is. What we do know is the center is going to be halfway in between. The center is going to be halfway in between. So therefore the center has to be halfway between the two foci. And what's halfway between negative 2, 2 and 4, 2 would be 1, 2. Therefore, again, we can get a decent start. Our h value is 1, and our k value is 2. So we can get a decent start on our equation. Now, the second piece of information was that the major axis was 10 long. So altogether, the distance is going to be 10. So we're going to have to, that means we're going to have to go 5 to the right of the center, and we're going to have to go out 5 to the left of the center to get a total length of 10. But that means that whatever the ellipse looks like going through those vertices, whatever it looks like, the distance from the center to the right-hand side is 5. Therefore, that distance squared is 25. Now, what's not clear, and here comes the tricky part, is what's the distance from the center to the top, or if you prefer to go to the bottom, of the ellipse. It doesn't tell us, it doesn't show us directly. That's going to be the value that goes under the y's. So how are we expected to find it? Well, we're expected to find it this time using our formula for locating focal distance. So we start with c squared is equal to a squared a squared minus b squared. Now we know what the a value is. We just found that. That's the 5. And we know the c distance is the distance from the center to a focus. And I'm going to put that in red. So the distance from the center to a focus would be like the distance from 1 to 4. So that distance is 3. So that means our c value is 3. And is that therefore an equation you guys can solve? Well, heck yeah. 3 squared is 9. 5 squared is 25. Move positive 25 to the other side by subtraction. 9 minus 25 is negative 16. And divide both sides by negative 1. So b squared is equal to 16. Now, if you might be tempted to take the square root of both sides to find out b, which is totally fine. But the number that goes in our equation anyway is going to be b squared. So you need not waste your time. And therefore, again, we have our complete equation. Okay, and I've got one more for you, and then we'll call it a day. All right, what if I were to give you the center, a relationship between A and C, A is equal to 2C in this case, and the location of the vertices? Is that enough info to get to our, to get to our equation? Well, let's give it a try. Again, start by drawing yourselves a picture. So the center is at 0, 4, so stay in the middle, go up 4. So there's our center. And of course, what that allows you to do right away is replace h and k with those two numbers. So we'd have 0 for h and 4 for k. So again, we have that part of it right off the bat. Okay. Now, the other information, I'm going to skip the a equals 2c for 1 second. The other information is that the vertices are at negative 4, 4, and positive 4, 4. And what that tells us, shows us, is that the distance from the center to the side of the ellipse is 4. Therefore, the number that goes under the x's is that distance squared, so 4 squared is 16. What we're short, though, what we don't know right now, is what's the distance from the center to the top of the ellipse. It doesn't show us, it doesn't show it anywhere directly in the problem. So again, what we're going to have to do is use the equation for focal distance. We have to use the equation for focal distance. Now we know what the a squared value is. We know the a squared value is, well, let me just do it this way. We know the a value is 4. We don't know the b value. That's going to be the distance from the center to the top. So that's fine, but I can't write down c squared. In fact, let me write this down. Doesn't do me any good, right, guys? Because that's one equation and 2 variables. Bad. Can't solve. So what I've got to do then is I've got to replace c with what it's equal to. All right, and what's C equal to? Well, let's see if we can figure it out. I'm going to take this chunker of information and just jot it down here. If A is equal to 2C, that's the given piece of info, right, guys? And we know that A is 4, can you then solve for C? Well, sure. All we have to do is divide both sides by 2, and therefore the C distance is 2. And now we're all set to go. 2 squared is 4, 4 squared is 16. Move the 16 to the other side by subtraction. 4 minus 16 is negative 12. And divide both sides by negative 1. So the b squared value is 12. And we have everything we need for our equation. Okay? So I hope that went okay. You'll have a handful of examples like that in your assignment, so please give them a try and let me know if you have any questions. Have a great day. Talk to you soon.